So this is going to be a quick video just showing how to set up Desmos to do the predictions like I did in the last one. I've picked a question here as an example, which is a question I wrote about whether deaths will spike again in the UK. But this is just illustrative. I'm not actually going to forecast on it. So let's download the data and see how to clean it up. Okay, so the first thing to do actually is just insert a blank column next to it. And what we're going to use that for is to translate the date. Desmos doesn't like dates very much, so I tend to just have increasing integers and then get those to correspond to dates. So let's get this oldest to newest, and then let's just put some numbers in here. Now, I presume there's going to be some sort of weekly pattern in the data, so we're going to want a 7-day moving average. Let's just do that now. So let's put it on here. Okay, now if we can paste them straight in, just you. Okay, so it looks like our green line is our sort of 7-day average, and our purple line is our raw data. It's a bit weird that it kind of lags here. Do I believe that, or do I think I've done something wrong? It's an average of the previous 7 days, so when the graph is very steeply increasing, you probably worked this out before me. When the graph is steeply increasing, it should lag. Okay, yeah, that makes sense. So let's now just look at the 7-day average that we have. Show you how to do a couple of things with it. I think the first thing that's really useful is if you want to force a line through the final data point, so 22364, then as I'm sure all of you know, the sort of equation of a straight line is y equals mx plus c. And you can add sliders for m and c, and then you can, like, if we scroll at the start, you can do this sort of thing. Now the problem with that is it's going to take you a while to get a line going through here. So what I suggest you do instead is you force it to go through this point. So instead what I'd say is use that equation of a straight line, and now you can pick your y0 and x0 to be these 2 points. Now you can see that we can change m as much as we like, and the data is forced to go through that last point. If you set these up as sliders, so how I'm doing that is I'm just clicking on it, and then I can choose the range. You might want to say, let's put this between 40 and 80. You can choose a nice small step, and then it can change really smoothly. Similarly for our x-intercept. And then we probably also want our gradient to be positive and fairly small. Okay, now we're moving this territory. While we're here, I'll show you a couple of other things which won't work very well for this at all. So if we have our data series here, you can actually ask Desmos to fit data to these points. The only slight difficulty is it really doesn't like it if there are spaces in rows. You see we have space in all these rows. So what I'm going to do is I'm just going to add in zeros for the numbers where the 7-day moving average wasn't well defined. Now what we should be able to do is type y1, which is the name of this list. Let's do a linear fit first. It'll look stupid, but we'll illustrate the point. y1 tilde okay, so it's tried to do a linear fit through the data. It's terrible because the data's not linear. So let's now just fit a cubic, as the US CDC once tried to do. Okay, nice, cubic fit, classic. Still useless, but you get the point. So we could fit like a nice sigmoid or something. If we think growth is going to be exponential, we could fit that. And the point here is, in some cases, you can get data that looks good, but as with before, like this is the best exponential fit to this line. So the conclusion here should not be that you should use this prediction. The conclusion should be an exponential fit is a bad fit.